A whole bunch of algebra.
A whole bunch?
Like I need the entire entire whiteboard full of numbers in order to do this. All right. So the question was, am I going to collect the package 9.1c? And the answer is no. I already gave you the answers. It was the third day that we did it. I forced you to do it in front of my face, right? We've done enough of solve by graphing. I said that we had to bring our graphing calculators every single day. We were going to use those to check occasionally answers and just to make sure that we haven't lost the ability to do these problems with a calculator. All right. I'm really scared to teach this class to you. I'm really scared, like I'm fearful, academically speaking. I don't think that most of you have the ability to concentrate enough to get this. Prove me wrong.
We have a very small attention.
Okay, prove me wrong. I know that I will get a couple people that get this. If you are seriously right now sitting there next to someone that will distract you and you know it, you need to move right now. This is not that class that you can sit next to someone who will distract you and get this. So I need 100% of your attention today. I like 100%. Okay? It's not that what we're doing is impossible. It's actually not that bad. I'm exaggerating slightly. But what is bad about it, I don't know where I'm sitting. What is bad about this is that it's one of those things that I have multiple people not get this. And it always boils down to, well, no, I wasn't really paying attention and I'm slightly confused. It can all go away if you actually pay attention. By pay attention, I don't mean like 10% of your attention. I mean 100% of your attention. All right, so write down your homework real quick. There's 16 of this. Listen also carefully. If you get started on this during student advisement, go home no more than like 20 minutes worth of work on this. If you've done most of this in student advisement. If you don't do any of this during student advisement, no more than an hour. For some of you, you're going to be done with this. I'm exaggerating, like it's not that bad. But for others of you, I know, one, you struggle at some algebra skills. So for some of you, this is going to be some challenging stuff. It's in the box right over there. Good. The last two techniques is what the whole chapter is about, by the way. It's solved by graphing. All right, we're done with that. The other 2/3 are the other two techniques. Why do we need 3 techniques to do one thing? It's because it depends what I hand you. I'm always going to hand you 2 equations. You're always going to figure out where do they intersect. But I'm going to hand you, no, look to your left.
Oh, you said a box, not a basket. What's a box?
I thought I said basket. Oh, no, I did. It's in the box. Yeah, okay, I get you. I did say it. I always call those boxes.
Why?
Because they're literally in the business world called, this right here is called in the business world this is called an in-box.
A turning basket.
Okay. So, I mean, I was in the Army way before I was a teacher, so it stuck with me that it's called a box. All right. So here we go. So if you have your calculator in your hand, put it down, right? If I don't have your attention, just accept the fact you're going to fail. But if I do have your attention, I can get you to where you can pass. Here we go. Well, it's been up there the whole time that I've been talking.
Maybe we actually want to listen to you.
Yeah.
We're paying too much attention. Yeah.
Okay. Have you ever heard the term gird your loins?
What? Nope. I did not.
Whenever you do something difficult, you might hear the expression "gird your loins."
No.
Right? Your loins are your region.
Not that one. Your butthole?
What did you say? Admin? No, you said something else.
He said region.
No, he did not. He said something else.
I said your region.
Oh.
Your butthole?
Well, that's part of it. Gird your loins is a phrase that you will hear occasionally when someone says, "Hey, you got to be careful. It's just got real." Okay. Gird your loins as a historical purpose means this. It means back when everyone didn't wear pants and you were ready to fight someone, what you had to do so you didn't get your butt kicked, because the person would literally pull you down by your dress and beat the crap out of you, is you gird your loins. That means you wrap it up so that you can fight, right? We use it now as an expression of, okay, gird your loins means you're about to do something challenging and difficult. That's what we're about to do. So gird your loins. All right. We haven't been doing anything difficult so far. In fact, most of you tore through that homework yesterday very quickly. One, because graphing or solving the system by graphing is pretty easy. It's ridiculously easy if you have a graphing calculator. It doesn't matter how ugly the equations are, as long as you can type into your calculator, you get to an answer. What happens if you don't have a graph or you don't have a graphing calculator? It's impossible to do, except that we have two techniques that make it possible. Okay, so the rest of the chapter is about these two techniques. 3 days for each technique. Okay, there are three techniques. The first one's called solve by graphing. We just did 3 days of it. The second one is called solve by substitution, next 3 days. And the last one is called elimination. Why do we need three things to do one simple thing, find out where the lines intersect? Because look at this one. They don't intersect at a lattice point. Your graphing calculator will tell you the answer. You don't have to, if you have a graphing calculator, you don't need substitution or elimination. You got a graphing calculator. Okay? But if you don't have a graphing calculator, which you will not have for part of the test, well, you got to learn these other two techniques. Okay, so we're done with that one. Now we're going to move on to the second of two techniques of gird your loins. Neither one of the last two techniques are easy. I will say most students find that elimination is, believe it or not, fun. Nobody likes substitution. Okay, so solving systems, like I said, we just did 3 days of this. We graph the two lines. We find where they intersect. It's pretty easy. All right, we get to an answer 2, 4. Great, pretty easy. With a graphing calculator, once again, it's really easy. But what happens, that's the big but here, what happens when the lines do not intersect at a lattice point, right? Well, I don't know where that point is. If I were doing it by hand, I mean, I can see it looks to be roughly, I don't know, negative 0.8 and positive 0.1, I'm guessing, and it literally is a guess. Turns out there's a way to find the exact number, substitution elimination. All right, so it also is a problem when one of the, for graphing, like doing it by hand, I mean, you can't graph that one by hand and both of these on the same graph. You can do it on a graphing calculator, but you can't do this one by hand. Today, I will teach you a technique to show you how to solve this in this particular case. It doesn't fall on a lattice point. You don't have a graphing calculator, and you can't graph it by, you can't graph 1,523 on a graph very easily, unless your paper is huge. All right, so it's called substitution. We use the solve by graphing method if it does in fact land on a lattice point, or you have a graphing calculator. Great, that's what you should do. If you don't, you use one of the other two techniques. The one that we'll spend 3 days on is this one, solve by substitution. We use this when one of the equations has already been solved for x or y, and it'll make more sense once we do some. That's when we use solve by substitution. If I give you two equations, I will always give you two equations, and one of the equations is already solved for y or x, you're going to use substitution. It's the quickest method. Okay? Well, why do we have a third one? Well, what happens if neither of the equations is solved for x? Well, then we use elimination. And you're like, well, it would seem like that would be the hardest one. This is actually the easiest one. If both equations are not solved for x or y, elimination is quickly done. And it is kind of cool. Unfortunately for us, we got to do the substitution one first, the one that nobody likes to do. I will say that we use this substitution technique throughout math. It's just not just for this one thing, this thing called substitution. In fact, in geometry, for those of you who are in geometry right now, how many times do we use substitution? How many proofs have the word substitution in it? A lot of them. We use this technique of substitution a lot next year when you take geometry. So solve by substitution. I'm going to give you two equations. Notice one of them says y equals mx plus b. The other one does not. You're like, well, I could make it say, agreed. But let's say you don't have graph paper. You don't have a graphing calculator, right? Therefore, we need a technique to come to the answer. When it looks like this, one of the equations is solved for either x or y. The other one is. And you don't have a graph. By the way, you got a graphing calculator, forget all three techniques. Put it in your graphing calculator. Okay. So we're going to use this technique, solved by substitution, when one of the equations I hand you is solved for x or y. I'll explain what that means here in a second. So here we go. Notice when both of them are solved for y, it says y equals mx plus b. You use your graphing calculator, solve by substitution. Okay. The only issue is this: you're never guaranteed, except if you have a graphing calculator, if you do this by hand, that you will find an answer. If it doesn't fall under a lattice point, then you're guessing what the answer is. Got a graphing calculator, always use it. But if you don't, then you look at the two equations and you see if one of them or both of them are solved for y, you use substitution. Okay. One of these is solved for these are two different ones. One of these is solved for y. I would immediately say solve this one by substitution. All right, enough of that. Let's just see what it looks like. There's no difference between this technique and what you see right there. It happens every time in a basketball game. What's happening?
You sub in.
You sub in, right? What does it literally mean? It means you replace one player, not with a different player, with the same player of the same position. If you lose your center, you don't throw in a guard, ever.
You could.
If you have to. But I'm saying by choice, you never do that. You have people that play center, people that play guards. You don't mix and match those. So substitution is when you're substituting like things that are exactly alike, not different people, obviously. What we're about to do mathematically is no difference in this picture right here. We're going to be doing substitution. All right. I'm going to solve this equation, which I just did, by the way. The answer is 2, 4. I'm going to solve that system of equation using substitution. So I already know the answer is 2, 4. All right. Here's what you need to do in box number 1. Do you notice box number 1 is blank? Okay. You need to write the steps down. And that's it. All you're doing, there's going to be a yellow box here. You're going to write the steps down. Then once we have the steps down, box 2, we'll do one together. All right, so here we go. You're just going to write down the steps. All right, please try to follow the logic. Some of you might get it the first time. Most of you won't get it until after we do 2 or 3, maybe 5 of these together. All right, here we go. Step 1, write that down in yellow. Get one variable by itself in one equation. It doesn't say both equations. Remember, solve by graphing. The ones that weren't solved for y equals mx plus b, you had to solve both equations. Porter, move your pencil. Ryland, move the pencil. Take one of these equations, solve it for y or x. It doesn't matter which one. It's not easier or harder. Just you pick one letter and you solve it. So I go to one equations and I solve it for y or x. Hey, it's already solved. There's nothing to do here. If it wasn't, we'll see that here in a little bit. If there wasn't, we will have to solve for either x or y. Okay? So you get one equation where it either says y equals or x equals. Either one is fine. Okay? That's step 1. There's nothing. This is why I gave you the first one. There's nothing to do there. Step 2, write this down, substitute.
Well, how are we supposed to substitute?
I'm going to show you the step here in a second. All right, once you have the word substitute, put your pencil down, look at the board. I will show you the substitution. Hey, player 1, player 2, they're both centers. Okay, player 1 has a last name. His last name is 3x minus 2. Player 2 has a last name. It's x plus 2. We're going to substitute one player for the other. This says wherever I see the letter y, what does it equal?
3x minus 2.
Wherever you see the letter y, you can substitute. What do you see right there? Wherever you see a y, you can write.
3x minus 2.
Wherever you see a y, you can write. That's the substitution. Instead of writing that letter y, I'm going to write 3x minus 2 because it says the letter y is exactly 3x minus 2. Well, I see the letter y right there. You're like, well, this one says, yeah, so I could substitute for that one if I wanted to. I'm not. I'm just going to substitute for that one letter y, 3x minus 2. I'm going to rewrite this. And instead of y, I'm going to write.
3x minus 2.
That's the substitution.
Oh, that's easy.
It's way too much work.
It is.
And then.
Oh, and this is just the start. All right, here we go. Hey, now I have an equation with one variable. I can solve it. Step 3. Now I'm going to solve for it. There's only going to be one variable at that point. Now I'm going to solve it. And it could be y if we were substituting for x, then we would be solving for y. In this case, we're substituting for y, we're solving for x. And it doesn't matter which letter we're solving for. Once we do the substitution, you just solve for whatever letter is there. I got an x. Hey, I got a 3x and an x. Which one am I going to move?
Yeah.
Subtract x from both sides. Add 2. Therefore, x equals, you just figured out half of the problem.
That's half of it?
All of this gets you just what x equals. Because remember, the answer to a system of equation is where the two lines intersect. They intersect at an x and a y. You just found.
You have to substitute for.
You got it. That was genius. All right. All right. It's called substitution because you do 2 substitutions. We already did our first one. Now we're going to do it again. Now here, tricky step. I take that and I go back, step 4.
And you put x into.
And I go back to either equation that I started with. I go back to either equation that I started with. And I let x be 2. And that will solve for y.
That's it? You kind of overhyped.
Well, we just have to write the answer.
That's so easy.
I didn't say it was, I just said it's, I said I'm going to fill the whole board full of numbers. All right. Well, I did say I hyped it a little bit. I did say that. I'm just going to say, well, prove me wrong. I rarely get a class where like everyone gets this immediately and they're doing great at it. I mean, that's why I got 3 days of it. I mean, it usually is 3 days and I still have 1 or 2 people like I need tutoring. All right, I'm going to take this x equals 2. I'm going to go either to the left equation or the right equation. I'm going to go to the left equation, writing this, you know, in box 1. By the way, you can choose y, and it doesn't matter which one you pick. Nathan, which one looks like the easiest one to use, the left one or the right one? Okay, we use the left one. We're going to let x be 2. We got some math here, right? We choose this one. We let x be 2. And by the way, it doesn't matter. We'll get the same. I'll show you here. But you can make your life a little bit easier choosing one that's easier to mess with. I'm going to mess with this one. So I would say I got some empty space here. I'm going to let x be the value 2. Therefore, y equals 4. Now, remember, the answer to a system of equation is a point, x comma y. So don't screw it up at the last step. The last step is to write the answer, x, y. So what am I going to write?
2, 4.
And guess what the easy mistake to make here is? You just write them the wrong way, right? So the answer is 2, 4. That's the answer. All of this mess just to get that. And by the way, we already knew the answer was 2, 4 because we solved it by graphing. Don't assume that it's going to be nice, friendly numbers tonight for homework. It'll be ugly numbers.
Thank you.
Generally speaking, there'll be some decimals or some fractions involved. We're going to do a couple of these with nice, friendly numbers, and then we'll do a couple real ones. Because remember, we usually only use this technique when it doesn't fall under a lattice. 2, 4 is a lattice point. And we're expecting to be 2.16394, comma 4.00387. That's what we will typically get when we do substitution. Expect it to get ugly. Okay, you just saw me do one. Let's do one together. You ready? Yeah. I used to have another video here, and literally Miss Newbern, because she uses my slides, she got YouTube pulled the video down because it was copyrighted material. I had a wrestler saying something from WWF, and WWF wrote Miss Newbern saying, "You can't show this video." Well, I still call it WWF, but it's, you know why it's not called WWF before? They got sued by the World Wildlife Foundation. Go figure. They were the original WWF, and they got sued, which is crazy. One's wrestling, and one's like polar bears. You know.
What did WWF?
That's why it's
for wrestling.
Worldwide
Fighting.
I don't know, but it used to always be called the WWF. All right. Anyway, here we go. Okay, box number 2. Let's do this. Step number 1. One of the equations you have to solve for either x or y. Merry Christmas. One of them already is. Okay. By the way, this is why you would use substitution. This is the classic. Hey, look, one's already solved for y. I'm going to use substitution for this sucker. Okay. Everybody good? Step 1. eventually we'll get to where we literally have to do step one. Once we learn elimination, you're never going to do step one because you're going to use elimination for the ones that you have to get a variable by itself. It's crazy to use substitution when you could use elimination. Okay, so the substitution, wherever I see the letter Y, I can write. Do you see a letter Y?
Yeah.
So right here, instead of it being Y, I'm going to write. That's the substitution. Instead of writing the letter Y, I'm going to write 3x. So I still got a negative 32. Common mistakes are you're copying things. You just copy down the wrong things. Porter, calculator, put it away. I know if I had that calculator in my hand, I wouldn't leave my hand either. I have a ninth grade boy who gave his calculator a girl's name because he's in love with it.
What's the name?
What is the name of his calculator?
Delilah.
No.
Francine.
Angela?
Ew, that's such a basic.
That's my mom. Jack? Is it Andy?
I can't remember. Anyway, every kid in the class makes fun of it. Right? He takes it well, but
Is it Jack?
he was like, this is my girlfriend. Whatever. All right. Here we go.
Was it McKinley?
No.
Was it Jack?
Yeah.
All right. You guys know too many people.
Jack's the only
I'm not saying anything.
Was it Matt?
I've already said too much.
Was it Ethan now?
All right. Up here.
What grade is it gonna go up?
Up here.
It said 9.
You can figure it out yourself.
It's Jack.
It's McKinley. It's McKinley.
No, it's Jack.
X plus 3x.
Yeah.
X plus 3x.
4x.
What do we do to both sides?
Divide.
Therefore, x equals.
I don't know. I'm not
Negative
doing that.
8.
I already did most of it. It's all good.
-8.
Negative 8.
Thank you.
All right. So we just did step number 1, 2, and 3. Step 1, 2, and 3. Solve by substitution. Okay. Last or second to last step is we take this value and we pick one. Which one is the easier one to mess with? Rowan is pointing to the one on the left. Do you agree?
Yeah.
By the way, it will work for this one as well too. Let's see. We let x be -8. Add 8 to both sides. You get -24. Well, this one's a little bit easier. We will still get the same answer. I'm going to choose that one. It's easier than that one. It's not that much easier, but yeah, it looks a little easier. So we throw -8 into that equation for x.
It's going to be a negative.
It is, and it's going to be
Like negative, like.
I already pointed it out.
Negative 24.
-24. Just be careful. Remember, your answer is written as an xy. It's the point where the two lines intersect. Where do our two lines intersect?
-8,
-8, comma, -24. You have to write that. That is the ultimate purpose of this, is to find the point where the two lines intersect. All right, how are we feeling?
Easy.
Good. I mean, if you literally are, that's the truth, then we're doing well. We're going to do this for 3 days. They get uglier as we progress. We have to, right? This is of the 3 main things that we learn in algebra. This is one of the 3 right here. Solve a system by substitution, elimination, and graphing. All right, box 3. Here we go. Box 3. Make sure you do it this time.
They're already both solved.
They are both solved. So for me, this one immediately screens substitution, right? Substitution. And it doesn't matter which one we substitute, right?
I would drop that.
Yeah, but what you're not guaranteed is that it falls at a lattice point. So you go through the hassle of graphing it, and you find out, oh, it's not a lattice point, then you got to use substitution.
Why do you have to?
Because you don't know at the start right now, does it fall on a lattice point?
No, just use your calculator.
No, I told you at the start. I said, if you have a graphing calculator, which of the 3 techniques should you use? The calculator, absolutely. But you don't have a calculator. Well, then you got to choose elimination, substitution, or graphing. I'm not going to graph this because I do not know if it falls on a lattice. I don't want to do extra work. It does though, right? But you don't know that at the start. So and by the way, once you get adept at substitution, right, then you use substitution because it's not that bad. All right, so wherever I see a y, I can write 2x plus 7. Hey, I see a y. So I can write 2x plus 7 for the y value. Hey, you said you were going to write this. The mistakes I generally see are you just copy things down wrong when you do the substitution. Kaylee, we good? Okay. Aiden? Say again, Kaylee? Okay, and there lies the problem of algebra. And she says, well, I know that I'm probably going to screw up some algebra. So yes, there's lots of steps here. And unfortunately for you, if you screw up the first or the second step, boy, does it go badly quickly. You wind up doing all this work with really ugly numbers, right? So it is absolutely fraught with error, right? Or fraught with terror because you're afraid that you're going to make a mistake, and you probably will, right? I've always said from the start, since I've taught this class, I said, hey, show me you know what you're doing and I will take care of you. I mean, you see me make plenty of errors, right? You can make lots of errors, but you should not be making an error of what to do, okay? All right, what are we doing to both sides here? Subtract x from both sides, okay?
But why subtract? X doesn't want to be subtracted.
Tough.
That's like,
Yeah.
But it's x's.
Then what are we going to do to both sides?
Subtract 7.
Subtract 7 for both sides. Tell me if I'm going too fast. So we get x is equal to negative 8.
Woo!
Say again? Because 2 is not attached to that by addition. It's attached by multiplication. So we can't subtract 2 from the very start. I got x's on both sides of the equation. Step 1, move 1. Always move the smaller one so we wind up with a positive value. Subtract 7 from both sides, we get negative 8. My x is done. Now we get to the y. We go back to left or right. Which one's easy? Left or right?
Right.
Okay, so I'm going to choose the one on the right. Okay. But you can use either one. It doesn't matter. I'm going to choose the one on the right. So negative 8 minus 1 is, so final answer is negative 8, negative 9, which Chris showed me at the very start. He was like, look, I got the answer right here. Agreed. You got a graphing calculator. Why in the world would you go through this much trouble? Okay. But you won't have a graphing calculator on part of the test, so you will have to do this. This is the easiest of the easy. We haven't done the more challenging ones. We're about to. Okay. So the first 3 that we did are pretty simple. Tonight for homework, a couple of them will be this easy, but then they crank up the difficulty. The way they crank up the difficulty is just, it's not friendly, the numbers that they use. And you won't get lattice points. You're going to get decimal numbers. Some of them are right. Okay. I had one more easy one. You want to do it, or you want to try more challenging ones?
Challenging.
Okay, let's go to a challenging. Okay. So we got step 1 now that we actually have to do. By the way, as soon as I teach you elimination, you won't do this ever. Never solve for a variable if you don't have to. It's just extra work. You can use, because I got it, we got to do substitution first, learn it, and then do elimination. Okay. All right. So there are good choices and there are better choices. There are no bad choices, but there's only good and better. Here are the rules. I think you probably already figured it out. What do you think, Rowan? Should we solve this equation for x or y, or should we solve this equation for x or y? Why that one? Because the y is not by itself. It doesn't have a number attached to it, so there'll be no division. All I got to move is the negative 2x, and we're done. So there are good choices. This is still a good choice. Subtract 4x, divide everything by 3. But notice, that's going to give you these ugly, ugly, ugly fractions. Make wise choices. Choose the easiest one. Your life will be better. Tonight for homework, every one of them, you're going to find one of the equations has one of the letters by itself. Choose that one. Make your life easy. I usually will have kids choose this one, and it can be done. Boy, does it turn ugly. That's your smartest choice. Who's lost on the smart choice and the smarter choice? Okay, good. So, good job. You chose wisely. All right. So I'm going to choose this one, solve for y. Rowan, what do we do to both sides? Add 2x to both sides. That's the equation now I'm going to mess with. This one is more complicated. Watch what happens. This is a brand new one. Hey, this says wherever I see the letter y, what can I write? No, you just watch me do it. You just watch me do it. Hey, check. It doesn't say y. It says 3 times y. So I have to substitute 2x minus 3 in for this y. That means I need parentheses. I got distributive property. Some of you might try to do that in your head. Be careful, Anna, right? You try to do it in your head, okay, if you're good at it, you won't make, I'll make a mistake occasionally if I try to do the whole thing in my head. A smarter choice would be to take that equation, put parentheses, and then write this, okay? Do you see what I did? The kids say, I don't need that, I'll just multiply everything by 3, and they do that in their head. It can be done. Chances are you might make a mistake. I'm just going to say, if I write it like that, I'm not going to make a mistake. Okay? 6x minus 9. Another mistake is you'll forget that it said plus 4x. You'll just be so excited that you're doing the distributive property in your head, you'll forget that it said plus 4x. Well, I agree. I'm not saying it can't be done. I'm not even saying you have to write that step. I'm just saying I see fewer mistakes when you actually write it. 6x and 4x?
18x.
What? Now what? Add 9. You see what I said? We're not going to get a nice friendly number. What do we get? We get 2.3. It's not a lattice point. Okay? You got that look. What are we doing to both sides? You got it. Okay. Sophia, yes? Don't say yes if you mean no. Okay. I believe you. Okay. This is as ugly as it gets right here. The non-lattice point is. We got to take this and go back to, where are my 2 equations? I've forgotten. Well, here's one, just rearranged. And here's the other one. Which one you want to use? The left one? So I'm going to use the left one because it looks like the least amount of work, right?
So can you use the...
You can use either, you can even use that one if you wanted to. It's the same equation, just things have been moved around.
Okay.
So you actually have 3 choices here. I'm going to choose the y equals 2x minus 3. It looks just easier. So I'm going to take this sucker right here, and I'm going to let x be 2.3. It's just a little bit. It's not that much bad. What's double 2.3?
4.6.
Minus 3?
1.6.
Okay, it wasn't that bad, right? Who's lost in what I just did? Here is your classical why you would need substitution. Graphing this by hand, you're not going to get an answer. Using substitution, we got the exact answer, and it wasn't that hard. Say again? Well, remember, you'd have to have this say y equals, so you got more work using, a computer in Desmos. You can just type it in exactly as it appears from the start. Okay? By the way, if you're doing this tonight at home and you want to check and you don't have your graphic calculator, you got your computer, use Desmos because you can type it in exactly the way it appears.
So cheap.
It's not cheating. At this point, if you're cheating, guess what happens?
Get the right answer.
No, I'm saying guess what happens?
You don't get the practice.
That means you don't get the practice. Therefore, you show up on test day and you don't have a chance.
That's not true.
Right?
You stay home.
I've started, even, I didn't have you guys for 7th grade, but 7th graders have never figured this out. I mean, homework is just a completion grade. You turn in a piece of paper with numbers on it, I give you credit. It doesn't matter, right? Well, if it's the wrong numbers, then we have conversations. I mean, I know when someone is literally cheating, and we have a conversation. But I'm saying, I don't care if the kid, well, I mean, I care in a sense, but I don't care whether you get it right or wrong on homework. I care that you do your homework. The kid that's doing their homework is learning something. Hey, I got them all wrong. I got to go to tutoring. I got them all right. Okay, I got this stuff. If you literally think that you can cheat on homework and you're doing something, you're not. Because you're not getting the practice. No, it's not you're stupid. I mean, some kids just can't think this through. It's not that they're stupid, it's just that they don't think to the very end. They can think about 10 minutes ahead. Oh, if I go online and copy and paste, I'm done with the homework. And then you never change the font. And then you turn a paper that's got 26 fonts and you think the teacher will never notice that. I mean, I see this, not me, but I see the English teachers all say, hey, look what this kid turned in. And it literally has 23 fonts on it. And sometimes the colors aren't even right. I mean,
Why don't you go to the drag it and then click?
And then plus what all the teacher has to do is simply when you turn in something electronically is copy, put it in Google, and Google will show you where it came from.
I got caught plagiarizing for doing that.
Well, I was not, in high school I was smart, but I was not smart. I thought back then we didn't have the internet, but we had these things called encyclopedias. And I thought literally you could just write what was an encyclopedia. It was the same idea. It was old school copy and paste, right? Literally I was copying it by hand.
Yeah,
but the teachers all knew this stuff. They're like, you got that from the encyclopedia. I was like, no, they know these things. Right?
I got caught and she's like, Marlon, you gotta change everything. This entire paragraph is all plagiarized. I was like, how would you know?
Yep.
You hacker.
Because all they do is copy what you wrote and put it in Google. Google will say it came from this website.
It did everything correctly though. I changed the font. I looked everything great. I don't know how she
You just reword it. It's just smarter to reword it.
Just reword it a little bit.
And by the way, that's the thing that I didn't understand. And it's not that reword it a little bit. It's just put it in your own words.
Yeah.
Okay. What did you eat last night?
I ate chicken nuggets.
Last night, Tristan had a meal that consisted of chicken nuggets. I took his words and put in my own words. Done. It ain't that hard. The kids are like, well, I'm just going to change an and put a comma there and change a few words. You're missing the larger point. Just read it and put it in your own words. It's not that much difficult.
Reading
By the way, look at these ugly answers. You ready to do this one? These are really ugly answers.
That's answer shaming.
Okay, it is. All right. Which one, Nathan, is easiest to work with? Left side or right side?
Left side.
Let Nathan talk.
I thought, Nathan, good job.
Why the right side, not the left side, Nathan? Because there's an X already by itself. I just need to move. Stop.
That's a good one.
I just need to move the 3Y. So this is box 5. Let's do it together. Here we go. This is the one you want to mess with. So I'm going to take the 3Y and move it to the other side. In other words, I'm going to subtract 3Y from both sides. What did I do here? Oh, I don't have the answers here. Okay, here we go. X is equal to negative 3Y minus 7. Yes?
No, yes.
All I did was move 3Y to the right side. You can. Subtract 3Y from both sides. You can do anything as long as you do it to both sides. Hey, this says if I see the letter X, I write. So I go back to the first equation and I do that substitution. So let's see, I got a 6y, that's still 6y. I got plus 5 times my new x, which is negative 3y minus 7. There's a whole lot of negatives floating around there. There's where your mistake will come. Okay? Riley, seriously, if you're not practicing this, it's not like it comes to you. You have to do the work. Do it. Grab your pencil, do the work. What? I haven't put it yet. Thank you. Equals 8. Distributive property. 6y, 5 times negative 3 minus 15y, 5 times negative 7 minus 35 equals 8. Yes? What? Let's do a problem. Let's get to an answer.
The answers are good.
I know. Good one. All right. 6y minus 15y?
9y.
Negative 9. So we get negative 9y minus 35 equals 8. Oh, this is going to be an ugly answer, right? Ugly answer, I would say leave it as a fraction unless it's a nice, perfect, good decimal. All right. Add 35 to both sides. We get negative 9y is equal to 43, right? Oh, man, is that ugly. I just added 35 to both sides.
That's pretty.
So we get negative 43 ninths. That's as ugly as it gets. You get y is equal to negative 43 ninths. Boy, is that ugly. Oh, by the way, that's half the answer.
And then you're supposed to plug that in.
Exactly. I said, and remember the reason we do substitution is because the point is not a lattice point. You get ugly answers when they're not lattice points. Math teachers generally always pick lattice points because it makes the grading easier on a test. But I will throw a couple of these in here because that's the whole purpose of substitution. Yeah. It doesn't. I can choose this equation right here. Where is it? When I solve, I can choose this equation and I can choose this equation. I can also choose that one. You can, you'll get exactly the same answer. Which one is easier, the one on the left or the one on the right?
On the right.
Okay, so I'm going to throw that into that. Ugh. Everybody okay?
Sure.
I'm going to throw negative 43/9 into this one right here. So I get x equals negative 3, there's the negative 3, times y. Y is parentheses negative 43/9 minus 7. Stop me if you're lost what I did right there.
Why?
Because that was my substitution. See it? It says if you see the letter y, you can write negative 43/9. Well, we're lucky here because some things cancel. Negative 3 turns into a 1, and 9 turns into a negative 3. Oh, man. It's still a fraction. So we get x is equal to, and I'm running out of space here. I've got a negative over a negative is a positive. So I get 43/3 minus 7. We're almost there. Common denominator? Common denominator?
I don't know.
Common denominator?
I don't know. It's just
Denominator, not numerator.
Multiple by 3.
3.
21 over 3.
This one already has 3, so we can
21
turn
over
this
3.
by multiplying both sides by 3, top and bottom.
21 by
21 over 3. And guess what 43 minus 21 is?
No. 22, 3.
What if I do like that?
No, go back to my original statement about if you have a graphing calculator in your hand, use it. If you don't, now I know some smart aleck's going to say, well, I've got one in my hand when I did the homework. No, you have to do this tonight for homework. How many of these did I put on the homework? There's not many. There's a couple.
2.
I don't know if it's 2, but it's no more than 3, right? This one is as ugly as it gets. As ugly as it gets. We're going to do this for 2 more days. Tomorrow, we're going to see what happens when we get, we're going to do more of this, but we'll see what happens when we have no solution, infinite solution. Remember in the graphic, we never got one for infinite solutions. We'll see that tomorrow. We'll do more practice of this. Plus, you're doing homework tonight, a little bit of practice. I said no more than how much?
3 an hour.
No more. You spend more than an hour on this because some of you won't spend more than 10 minutes, I know. Others of you who are good students will try hard. And you might run into problems. Do not spend total of an hour. If you spend 30 minutes and student really spend 30 minutes, student advisement, don't spend more than 30 minutes at home doing this. You will get aneurysms from doing this sometimes. Okay?
What if you don't get it done then?
That's fine. I just want you to make an effort. We got 3 days to do this, right? So plenty of practice days ahead of us. You can. Aneurysms are really bad, right? And the reason why is it's a skull, right? Inside your skull, what happens when things expand? Well, it doesn't. It's a thick skull, right? It's hard to break your skull.
Internal bleeding.
Right. Guess what happens?
You die.
Nothing pops, but the blood gets larger inside your skull, like it bleeds out into your skull, inside your skull. And then what's also inside your skull?
Your eyeballs.
So as the liquid continues to grow inside your skull, guess what happens to your brain? It gets shriveled up, and that's what kills your brain. Right.
What if you don't have frontal lobe?
Well, then you have some space. I forget. I'm not the scientist. I forget what the frontal lobe is. That emotions?
No, it's like the thinking and the learning and the behavior.
Behavior, learning, all that.
Now I get the joke. All right. How do you feel about this? Yeah, I never get a student that, well, except for the student's probably an engineer, math person that really loves substitution. Never. Elimination, believe it or not, and it's more likely it's because substitution is so hard and so much algebra involved. I will get plenty of students look at elimination and say, well, that's pretty cool. I like that. It's a whole lot easier. I'm just saying, I do too, but I'm a math person. Right? Right, yeah. All right. We're not going to do any more than that right there. No more than an hour homework. And then Rylan, you got to do this. You don't get to be an expert at this by watching someone do it. You got to do it.
I mean, some people learn better by watching.
That's, you notice that's why I always have you watch me do the first one, and then we do one together, and then we do one by ourselves. Because of that very reason that some people need to watch someone perform the procedure first rather than do it. I was always like that. Like I got to see someone do it. All right, anyone online live right now? Mike or Haley or who else? Josie. No one's live. All right, good luck doing your homework. Send me an email. Don't. Some of you will do fine. Some of you might have some challenges on this. We're going to do it for 3 days. I will guarantee you that if you try this for 3 days, by the end of the 3rd day, you will be experts at this.
You're amazing. You've got it. Go.